Hi, this is Anna, and this is a tutorial in Finite Mathematics. In this video, we're looking at Chapter 1, Section 2 of the book Finite Mathematics, and this chapter is about Venn diagrams, tree diagrams, sets, partitions, and this particular section is about sets and partitions. We're going to be looking at one of the recommended homework problems that one of the instructors has recommended. This is problem 29 in Section 1.2. A set X with the number of things in X is 60. So, one of the things I always do is as I'm going along, I just go ahead and write everything down. So we're going to say the number of things in X is 60, and this is notation. So this n with the parens around something means the number of things in that set is 60. And this has been partitioned into subsets. And so partition just means, if the set of X was a pie, a partition would be the slices. So when you add all those slices up, you get a whole pie, right? And I mean a pie, not like a mathematic pie. So this has been partitioned into subsets: X1, X2, X3, X4, X5, and X6. So that's our first sentence, and I'm going to take a moment and I'm going to explain why this sentence right here is so very important. So what these partitions mean, and we're actually going to go ahead and choose a different color. We're going to go to a blue. This means that the number of things in X1 plus the number of things in X2 plus the number of things in X3 plus the number of things in X4, plus the number of things, getting a little crowded there, in X5, plus the number of things, getting my plus signs too, plus the number of things in X6 is equal to the total number of things in the set, which in this case is 60. And this is what partitions are all about. Okay, typically they'll ask you how many things are in one of these subsets, and you have to use this concept right here, this number of things in X1, X2, X3, X4, X5, and X6. When you add all those together, that's your big pie. Again, cherry pie. That's pretty much the fundamental concept from this chapter. So we're going to go back to our black, and we're going to continue on with this problem. So what do we got? We know that the number of things, well, I'll actually read it from the book. If the number of things in X1 is equal to, that's a 1, the number of things in X2 is equal to the number of things in X3. Okay, I can buy that. So those three slices of the pie are the same size. And the number of things in X4 is equal to the number of things in X5 is equal to the number of things in X6. Okay, so again, here's another size of slice, but they're all three the same size. So X1, X2, and X3 all have the same number of things in them, and X4, X5, and X6 all have the same number of things in them. That's what they're telling us here. And the final bit of information, and another important bit for this problem, and this is a pretty typical problem, is saying that the number of things in X1 is equal to 4 times the number of things in X4. And that's this problem in a nutshell, right there. We've got to use these facts somehow. They wouldn't give you the information, typically, they're not that mean, unless it was useful. So what are we asking here? They want us to find the number of things in X1, so the number of things in X1 equals question mark. Okay, so that's our question. Here's the information we have. This is, it may not look like it, this is a pretty basic algebra problem. So a lot of finite is algebra. If you're not comfortable with algebra, you're potentially going to run into some problems. So you want to make sure that you're pretty comfortable with algebra. So, and again, this n and x thing, it looks like that part's algebra. This is all notation. This n of x1, let's go ahead and go to a color and talk about that for a second. This whole bit right here, this n, with the parens around the x, that just means the number of things in that set, and so that is actually not something we can just plug straight into. So we're going to go ahead and we're going to make some substitutions, and this is a trick that I like to use. You can do it a different way, your instructor might have you do it a different way, but this is what I like to do. And I'm going to say that since n1 is the number of things in x1 is equal to the number of things in x2 is equal to the number of things in x3. I'm actually going to do my substitutions in a nice dark blue. I'm going to call this a, and that's some random number. We don't know what it is yet, but we know that that a is equal to the number of things in x1, the number of things in x2, and the number of things in x3. Okay, so the number of things in x2 is equal to a, so on and so forth. We're not adding anything. And we're going to say, since the number of things in x4 is equal to the number of things in x5 is equal to the number of things in x6, we're going to call this number b. And so again, we don't know what that is. These are like pie-sized slices. We don't know how big or small that slice is, but we're going to figure that out. Okay? And so let's see what kind of substitution we can do. Well, let's first go up here, and let's do substitution in this big one that we were talking about, that I was saying it was so important. So the number of things in x1, which is a, plus the number of things in x2, which is a, plus the number of things in x3 is a, plus the number of things in x4, which we've called b. Again, these are just numbers. We don't know what they are yet, so we're just using these as placeholders, plus the number of things in x5, plus the number of things in x6. All these added together are 60. Okay, well that kind of looks like math, but the problem is we can't really solve that. Why? Because we don't know exactly what a and b are unless we can find a way to relate them together. And that's where this part comes in. This n, this number of things in x1 equals 4 times the number of things in x4. So we're going to do a substitution in that one. And so the number of things in x1 is a equals 4 times the number of things in x4, which is b. Okay, so now we've got two formulas. And we can use these formulas, we can use this second formula, the one I'm putting arrows by, to solve the first formula. And it's basic algebra, little intimidating, maybe, maybe not, but let's go ahead and do it. So the first thing I'm going to do, since we're trying to figure out what the number of things in x1 is, which we've called a right here, we're going to go ahead and solve the second one for b. And that seems a little reverse, but you'll see why I'm doing it. I think it'll make sense to you then. You could solve either of these. You just have to know how to get to your final, what are you trying to figure out thing. Okay? So we're going to solve this a equals 4 times b, and that's 1/4 a equals b. And this is how I would sit down and solve this problem for a test. And so now we've got this new substitution, and we can substitute this into this problem up here, right? So we're actually going to keep our a's, because in the end we're solving for the number of things in x1, which is a, right? And so that's the easiest way to do it. And then we're going to sub for all these b's, we're going to sub 1/4 a in. And yeah, it's some fractions. These are a's, not anything else. And this equals 60. It's kind of hard to see all of this on one page because it's a little wide, so sorry about that. But let's go ahead and use some algebra and make this a little simpler, because that would be kind of gross to solve as it stands. So we can turn this a plus a plus a into 3a plus, and we can turn this 1/4 a plus 1/4 a plus 1/4 a into, getting ahead of myself there, 3 times 1/4 a, right? And that thing equals 60. Okay. So to add 3a plus 3 times 1/4 a, well, let's go ahead and get rid of that 3 times. Order of operations here, right? Multiplication happens first. Okay, so we've got 3a plus 3/4 a equals 60. And so let's try to combine this 3a and this 3/4 a. And we're going to do that by turning this 3a into a fraction. And so I'm going to multiply the top and the bottom by 4, so that I can turn it into 12 over 4, which is the same as 3, right? Plus 3/4 a equals 60. And we're going to turn this into 15 over 4 a equals 60. And then we need to move that 15 over 4a to the other side, or 15 over 4 to the other side, so we're going to do a equals 60 times 4 over 15, because remember, you flip it over when you're dividing by a fraction, so it turns that way. And that's a equals 240 divided by 15, and that is a equals 16. And so what was our initial question? Well, let's go ahead and zoom back out, check it out, see if we can find what it was. And it was, what is n the number of things in x1. What is this? This was our question, right? And so we said right here that we were going to say that the number of things in x1 is equal to a. And so we solved for a right here. So that means the number of things in x1 equals a equals 16. And 16 is our answer.